Brain development is an incredibly complex topic, and there's so much of the brain that we're still learning. If you saw my last lecture on neuroplasticity, we learned how the brain is always adapting and changing as we experience new things well into older adulthood. Babies are constantly learning about the world. They're experiencing new experiences. They are learning from people's interactions with one another. They're learning from facial expressions or staring at you at the market. Babies are constantly taking huge swaths of information and trying to process that. Babies have what are known as critical periods. I'll write that for you here now. Critical periods are a time of our lives where we take this information and that information actually affects how our brains develop and grow. How our brains develop and grow then affect how we act in the future. So babies experience their first critical period between the ages of 2 and 7. This is where we learn skills and abilities like speaking. It is believed that babies that do not learn how to speak between the ages of 2 and 7 may in fact never be able to in the future, or it may be incredibly hard to. This is one reason why kids don't have an accent when they learn a new language at an age earlier than 7 or 8. Now I'm going to talk to you about a study involving critical periods. In this study, there were two groups. A group of babies raised in a family between the ages of 1.5 to 3, and then babies raised in institutionalized care, where they may have not received as much attention and experience with facial expressions. For the study, the methods involved the babies being exposed to faces, sad, happy, or angry. And then those faces were either matched or mismatched with a fake word that had a sad, angry, or happy tone. The babies were then attached to EEGs and shown those faces with those tones. The results of the study found that babies from families had a higher, more sensitive response towards faces that matched with tones. That exposure in settings where babies could watch people, interact with people, and see those facial cues were more sensitive to those faces and those tones. This study is just one example of the idea that in addition to shelter, food, and water, babies need love, attention, and interaction with other people. So we know that during critical periods, our brains are processing large amounts of data and trying to interpret the data that affects our brain growth, right? So how do we learn that information? We learn that information through things such as pheromones, facial expressions. If you've ever seen a baby staring at you at the store, you know what I mean. As well as something as simple as heartbeats. These are just 3 examples in which babies are interpreting information that can actually affect how their brain develops. Let's talk about serve and return. Serve and return occurs when babies enact some form of behavior, whether that be a smile, holding your hand, or a little giggle, and their caregiver response. This causes a release of dopamine, which is the excitement neurotransmitter, the rush we feel when we go on a roller coaster, or the thrill-seeking neurotransmitter, and oxytocin, which is a neurotransmitter involved in forming relationships. It's our happy neurotransmitter. It's what's used when a mother gives birth to a child and forms that connection between the two. So oxytocin and dopamine get released in the baby, encouraging the relationship as a result of that serve and return, therefore encouraging the behavior. So serve and return, it's going to result in an increase in oxytocin, an increase in dopamine. During serve and return, we also experience proliferation and regression that are both helpful to neurodevelopment. We have, on the proliferation side, we have what's known as neurogenesis, is the development of neurons within our brain cells within our brain. And then we also have what's known as synaptogenesis, which are the development of synapses or connections between neurons. Then on the regression side, we have what's known as pruning. Pruning is what removes the neurons and synapses between the neurons that aren't being used, that aren't useful to the brain. And as a result, pruning allows the brain to save space and use that space towards the development of neurons that will be affected and will benefit development. So regression, proliferation, both are essential to the baby's development, as well as oxytocin and dopamine in reinforcing that behavior that results in proliferation and progression. So what happens if babies don't experience that serve and return? Well, if babies don't experience that serve and return, they don't get this proliferation, this progression. They don't get this dopamine, which in turn affects their encouragement of relationships, or should I say, results in a discouragement of relationships. They do not get that thrill. They do not get that bond encouraged as a result of the neurotransmitter not being released. This can affect them much later in life. It can affect how they form relationships in the future, their desire to form relationships. Oxytocin is also important in affecting our amygdala. The portion of our brain that is responsible for our fear response. Put that right here. Fear. And oxytocin also affects the nucleus accumbens, which affects our reward pathway. So a lack of oxytocin can affect the regulation of our nucleus accumbens and our amygdala. The amygdala, nucleus accumbens, and prefrontal cortex form what's called a triadic model. It's a concept I'll get into later in this lecture. And without oxytocin, that triadic model, these parts of the brain can become unbalanced in regulating one another, and as a result, can negatively impact the baby's development and their relationships with others in the future. Studies have shown that as a result of a lack of serve and return, children have a harder time paying attention, have a harder time forming relationships. With neglect being the #1 source of abuse in the United States, this just shows the severity and the long-term effects that a lack of serve and return can have on a child and their future as adults. Okay, we talked about serve and return. We talked about neglect and the effect that can have on serve and return, and as a result, affect how a child develops and the relationships both in childhood and in the future. Now let's talk about another impact neglect can have, and that is called ACEs, or adverse childhood experiences, otherwise known as ACEs. ACEs occur when our brain experiences too much stress hormone, cortisol. Too much stress hormone results in what's known as mental trauma. Mental trauma can affect how our brain develops. It can affect the mental illnesses or even physical illnesses that we develop later in life. Mental illnesses as a result of trauma caused by ACEs can be anxiety, depression, alcohol, and drug abuse. All right, so I think it's worth noting that just because we experience an ACE or ACEs, it is not some death sentence. It is not as if we are doomed to suffer from anxiety, depression, obesity, heart disease for the rest of our lives. All ACEs are a possibility of an increased chance of cortisol in the brain that resulted in a mental trauma. That does increase our chances of these occurring. There are people that have experienced traumatic events that they themselves aren't traumatized by. The brain is really complex, and humans are really complex, and everyone is different. With this said, it's important to seek help if we've experienced ACEs, and we do believe that has resulted in some form of trauma. That help can come in the forms of therapy, other mental health resources, as well as medication. And in doing so, we eliminate that risk of anxiety, depression, obesity, heart disease, cancer that is associated with adverse childhood experiences. So we talked a lot about the brain development occurring as babies and during our childhood. Now let's move our focus towards adolescence. Adolescence occurs during a time when our physical, psychological, and social interactions shift from childhood. This is a time when we tend to prefer and value our relationships with our friends over our parents. This is a time when we experience sexual maturity, and we start to begin learning talents and skills that can affect us well into adulthood. So the data behind adolescence is that a teenager can process risk, assess reward, assess their own vulnerability in situations just as well as any adult. So why are teenagers associated with making risky, dumb decisions? So once again, it all boils down to brain development. Certain animal studies have shown that an increase in sex hormones such as testosterone and estrogen have been correlated with myelination, which is the formation of the myelin sheath of our neurons that insulate our neurons and allow for faster reactions between neurons. So that boils down to sex hormones resulting in myelination. Myelination results in the forming of your myelin sheath, which is a part of your neuron that increases the firing between the neuron, increases the rate of firing between the neuron, right? So these sex hormones that increase as a result of puberty results in an increase in brain development. The problem in teenagers lies in that brain development is not all equal. Certain parts of our brain develop faster than other parts of our brain. And so now I'm going to talk about something known as the triadic model, which essentially is one theory as to why our brains are so risky when we're teenagers. So the triadic model boils down to three parts of our brain. You have your prefrontal cortex with its executive function. This basically means it regulates your inhibitions. It's more logical. It's the control part of your brain. It regulates your amygdala, or the fear, strong negative emotions such as fear, parts of your brain. Then interacts with your ventral striatum, or the reward aspect of your brain, right? But in adolescence, this brain development does not occur all at once, like I just said. So we have an increase in the amygdala, so we have a development in the amygdala, we have a development in the ventral striatum, but the prefrontal cortex is not fully developed until the age of like 25. So we have a strong reward pathway. So we have a reward seeking pathway that's very stable, but the harm avoidant pathway that would be created from a fully developed prefrontal cortex is not developed yet. As a result, we get the behavior we often associate with teenagers, that risk-taking, thrill-seeking. An evolutionary benefit to the triadic model. Why hasn't evolution weeded this out and removed this risk that this thrill-seeking behavior that we want to pursue as adolescents? One theory is that this risk is essential to learning about the world and the environment. How many times have we been told, don't touch the hot oven, don't touch the hot pan, over and over again, until we touched it and learned the hard way to never touch it again? This is the same idea that during our adolescence, when our bodies are healthier, when we can heal faster, when we've developed the sexual characteristics, the secondary sexual characteristics that make us bigger, stronger, that we go out and experience the world so we don't make the same mistakes when we're full-fledged adults and make that risk that could endanger us, that we may not survive from at that point, and as a result affect our families. Another theory is that the triadic model reinforces risk-taking, thrill-seeking behavior that benefits us in society. That boldness that's associated with positions such as successful CEOs, high corporate jobs, is actually encouraged, and therefore as teenagers, once we've developed the secondary sex characteristics that make us stronger, more stable, that this triadic model actually reinforces these traits that allow us to succeed in a social hierarchy. So how else do we know that the brain is affected during adolescent years? We know from a 2018 study that teenagers crave mutual validation. I feel like that does not come as a shock. There is data on the fact that teenagers crave the validation of their peers over that of their family members. We also see teenagers being attracted to apps such as Instagram, Snapchat, social media that allows teenagers to find this validation amongst themselves through forms of a liking system. All right. So what are other ways that teenagers experience changes in their development, and how does that affect their actions during this time? Well, there was a 2018 study that found that teenagers crave validation, mutual validation amongst one another over that of their family. So we have mutual validation. Teenagers were much more willing to engage in social media and we're very fond of image-based social media that involve liking one another. We also have that teenagers were more susceptible to strong emotions such as stress. There was a study conducted with adolescent rats versus adult rats. The idea being that because these rats, the adolescent rats, have not had fully developed prefrontal cortexes, which we've already established is involved in regulation and emotion control, that they would react to stress worse than adult rats. In the study, the rats had their pups removed, and it was found that adolescent rats that experienced this experienced much greater duress, so a significant amount of duress over that of adult rats, as well as a reduced amount of neuron density. And this goes back to the idea that the stress we experience in our lives can have a major effect on our neurological development. Because the adolescent rats had not had a fully developed prefrontal cortex, they were much more susceptible to stress, and their development was affected as a result, according to this study. So now that we know a bit about adolescent development, let's talk about inhibitors to adolescent brain development. We know that the cliche of lack of sleep and poor nutrition can affect development, as well as ACEs, adverse childhood experiences, which we talked about before, as well as, again, a cliche, smoking and alcohol consumption. So these 3 bullet points are common inhibitors of adolescent brain development. Once again, these are incredibly important to avoid, as we know that brain development can very much impact our actions and thoughts much further into the future, way beyond our adolescent years. Not only is it good to avoid these inhibitors, but also through actions such as mindfulness and therapy, we can combat some of the problems we experience as adolescents, and in turn have our brains develop in a healthy fashion that enhances our thoughts and the way we act much further into the future. So we've talked about brain development occurring in babies. We've talked about brain development occurring as children into adolescence. Now it's time to talk about brain development during adulthood. Brain development during adulthood essentially stops at the age of 25, where we develop a full prefrontal cortex, or PFC, as I like to call it. Once again, the PFC is responsible for our executive functioning, which involves emotional regulation. It involves our inhibitions. This is where we see our triadic model getting rebalanced. Where before, our triadic model was way out of balance with our amygdala, ventral striatum, and PFC being incredibly unbalanced amongst the 3 of them, and really reinforcing that reward-seeking, thrill-seeking behavior that we associate with teens. Now, we have a rebalancing between our PFC, which gives us executive function, which allows us to regulate. Those inhibitions stop us from making those dumb mistakes that we do during adolescence, and we get a balance between the ventral striatum and our amygdala. So we're actually full-fledged adults at the age of 25 years old, approximately. Now let's talk about brain degeneration. This portion of the lecture is going to be on Alzheimer's. So, what is Alzheimer's disease? Alzheimer's disease is a neurodegenerative disorder that occurs in 60 to 80% of dementia cases. Other forms of dementia include vascular dementia, which affects more of your problem solving and logic rather than your memory. Lewy body, which affects which has a more rapid onset of symptoms compared to Alzheimer's. You can experience really severe symptoms such as hallucinations within a year of diagnosis. So I'm just going to write rapid severe symptoms. And then Huntington's disease. And Huntington's disease has a physical effect, such as mobility, affecting like the way you walk, the way you move your arms. So what causes Alzheimer's disease? We believe there are two things that cause Alzheimer's disease. We have tau protein fibers and beta amyloid plaques. These are the two things we believe cause Alzheimer's disease. Part of my drawing, but here is a healthy neuron in a patient that wouldn't have Alzheimer's. Now, a patient that does have Alzheimer's, you would begin to see little neurotangles, tau protein fiber tangles, all throughout here. And then you would have these, what are called beta amyloid plaques, that form all around the neuron. It's actually interesting, in Alzheimer's patients, you actually see a opening of their ventrals. The brain literally begins to almost unfold as a result of the disease. As a result of these tau protein fibers and these beta amyloid plaques, you begin to see a lack of communication between the neurons, which can result in cell death, basically the degeneration of the brain. And as a result, we get the symptoms of Alzheimer's disease. Whether these tau protein fibers and beta amyloid plaques are causational or correlational is the question. We do know they're associated with Alzheimer's. We do know that we see these in Alzheimer's patients, but is there a deeper problem occurring in the brain? We don't know. There are 3 stages to Alzheimer's disease, beginning with the mild stage. During the mild stage, a patient may have problems organizing. They may experience light forgetfulness. So that would be like forgetting names. It would be misplacing objects, potentially, misplacing valuable objects. During the mild stage of Alzheimer's, patients can live independently, and oftentimes their symptoms can go unnoticed. What's concerning with the onset of Alzheimer's is that patients tend to be embarrassed and tend to withdraw. And that withdrawal can worsen symptoms and result in other mental illness issues such as depression and anxiety. So after the mild, we go to the moderate. During the moderate phase, the forgetfulness increases. Forgetfulness of, say, your own name. Forgetfulness of name, identity, or your address. You have patients that may have loss of bowels. Patients are incredibly confused. These symptoms again worsen as the years go by, but patients may be confused, disoriented. They have a tendency to wander. Patients have a tendency to act on compulsions, and in some cases even change their personality. Personality changes. Personality. All right. And now we move to severe symptoms of dementia. Severe symptoms of dementia. At this point of a patient's life, a patient is living in assisted care. They cannot live independently. This can take place in forms of family member taking care of them, or assisted living in a healthcare setting. During severe cases of dementia, we have a loss of awareness in surroundings. We have a vulnerability to infections, such as pneumonia. And then, again, around the clock care. All right. So again, Alzheimer's disease, we have our mild symptoms, which lead to moderate symptoms, which can last several years, become increasingly worse, and then we get to the severe symptoms. It is worth noting that these symptoms can range from person to person, and just because one Alzheimer's patient can experience a range of symptoms that another Alzheimer's patient never experienced. Okay, so we talked about the symptoms of Alzheimer's disease. Now let's talk about treatment plans. So currently there is a controversial medication on the market called Aduhelm. And the controversy lies in that research papers have published very mixed results. Not only have there been mixed results, but the cost of the medication can be almost $560,000, right? And multiple clinics have come out saying they don't support it. Some have said they do. To my understanding, the Alzheimer's Association does support the drug, though, again, the FDA approval was expedited, and multiple papers have been published saying that the drug's ability to decline the cognitive degeneration has no significant results. I also wanted to talk about another controversy of Alzheimer's disease, and that is beta amyloid, or AB56. It came to light that 17 years ago, a paper was published with falsified data identifying a beta amyloid called AB56 as a cause of dementia in mice. And so for the last 17 years, researchers have based a lot of research on beta amyloid AB56. And now that the information has come out that the data has been falsified, the public has been concerned, thinking a lot of Alzheimer's research has been thrown out the door. So what now? Well, beta amyloid AB56 is not the only data that we've built a lot of Alzheimer's research on. In some cases, there were researchers that couldn't identify AB56 as a beta amyloid that causes dementia, that causes Alzheimer's. And instead, there has been Alzheimer's research that is based on other aspects of Alzheimer's disease, such as the tau protein fibers that I mentioned in the earlier lecture. AB56 was not replicated in other studies. And so there has been Alzheimer's research that is not based on beta amyloid AB56. Alzheimer's research has followed other correlations with Alzheimer's, such as tau protein fibers. And so I think this ultimately underscores the importance of the scientific method, in that although we build on one another's research, we also need to replicate these results. And in doing so, the Alzheimer's disease research isn't doomed. Actually, we are still studying other leads, such as the protein tau. All right, so now is our conclusion. We're going to recap everything we learned in this lesson. So we began talking about brain development and babies. We talked about how babies begin developing as soon as they're born, to the age of 25 years old. And how babies experience what are known as critical periods. These critical periods are where we take on a large amount of information that affects how our brain grows and develops. And this information and this brain development can affect our actions and our thoughts much later into the future. One example of our critical periods was between the ages of 2 and 7. We learned language skills. And by that, I mean the ability to simply speak. It's theorized that if we don't learn how to speak during this critical period, we may never learn how to speak, or at least have a really, really difficult time learning how to speak. We talked about serve and return. The idea that babies will do behaviors and receive a response from one of their caretakers. And in doing so, that releases neurotransmitters that help in brain development, as well as aid in the formation of the triadic model. We then talked about what happens when there's a lack of serve and return, the dangers of neglect and adverse childhood experiences, or ACEs. We talked about how ACEs can increase our susceptibility to mental and physical disease, ranging from obesity to anxiety and depression. Then we talked about adolescence, where we talked about risky behavior in adolescence and how that is incorporated with brain development. We talked about the triadic model, which is one explanation of adolescence risky behavior, and that is the relationship between the amygdala, the ventral striatum, and the PFC. The amygdala being responsible for our fear response, and the ventral striatum being responsible for reward, are fully developed, while the prefrontal cortex is not. This encourages a reward risk-taking behavior and a lack of executive functioning from the lack of fully developed PFC. We then talked about brain development in adults, where we talked about how this triadic model rebalances once our PFC is fully developed at 25 years old. Then we moved on to older adults, where we talked about brain degeneration in the form of different dementias, one of which being Alzheimer's disease. Last, I mentioned two controversies with Alzheimer's disease, being the falsification of the beta amyloid paper, AB56, with a note that not all research has been based on beta amyloid AB56, and that leads following tau proteins and other research are being conducted. So it's not a lost cause. And then I mentioned a new drug that we see, on the news in Alzheimer's research, and the controversy and conflicting opinions with that drug, including its price and also the amount of papers that have been published not finding significant results or finding little significant results. And yeah, that is my lecture. Thank you everyone for listening, and I'll see you soon. Bye.